Hey guys, it's me, Mega. Today I challenged myself and my anxiety to a daunting test of wit and soldering, only known to mankind as simply the Discipline65. Yes, I hate my lungs, that's why I chose to flood them with solder fumes. No, I'm kidding, I put a mask on since we have masks everywhere now. My soldering fan was not working anymore, so I had that. But anyway, I digress. I should stop blabbering now. Here's the parts. Banana splits. Lubed with Crytox 205 grade 0. For the keycaps, we're going for the Geekark Black on white. I love this set because it just works no matter what the case, because it's white. The case is 3D printed, although it is very sturdy and quite heavy for what it is. It still needs a bit of tender love and care. And by tender love and care, I mean sanding, hitting it, and making it cry a little bit. No, it didn't cry, it just sanded it and then painted over it. For the plate, we decided to go for a PC plate that is meant for the KBD67 Mark II. And finally, the main kit, the Discipline65. I know it's been out for a while, and this is actually a V1 version. We didn't bother with the V2 version since the only difference is having the ISO compatibility, and since we're going for an ANSI layout, it doesn't really matter. First off, for the case, because I plan to make it an even more solid piece of plastic, by adding wood though, that the internet said would be a great post-process thing for 3D printed materials or things. But I could argue against it, but I'm a noob, so what do I know, right? I might have done something wrong, but eventually I went with sanding sealer that should be applied inside and outside of the division, like as in all the spaces in the case or the part that you're connecting. This is essential because you need to fill up the spaces, or they create air pockets, which will also create problems of cracking on the weak points, which, believe me, I had my fair share with this build. So I wanted to solder all the other components first before soldering the USB Type-C port because I was just plain nervous for that. The USB Type-C port had so many pins and they were so small and they were just bunched up together. But I guess that's the challenge of it. Mostly I didn't mind all the other components, but the real problem for me was the USB Type-C. With these types of keyboards, you don't really know if you did a good job until you actually soldered everything. So the hardest part about this board was actually the whole troubleshooting, especially since the first plugin that I did on this board just didn't light up. It wasn't working. So I tried to Google around, I looked for a solution, and turns out the board is a lot more bare bones than you think it is because even the firmware isn't burnt on the microcontroller. So you had to completely go from the ground up. It's really a bare bones as it can get for a keyboard, that is. After modding the stabilizers, the client wanted the board to be hot swap as well. So I had to solder in some Milmax sockets on the board, which I'm not always a big fan of, but then for this board, it actually was a good thing that we went for it, since the plate doesn't have the same screw holes that you are supposed to get for Discipline65, since it is for a KBD67 Mark II. So it turned out actually better than we had hoped, because now you can disassemble the board with no problems. Unlike if we soldered in the board, you can't really take it out of the case anymore, since the case is 3D printed and fully covered all around. Oh yeah, we have some peel porn for all you guys who like these. And this one's a clean one. Ignore the awkward arm ninjutsu things I do for you people. Enjoy the peel. Let's do some quick keycap installation magic here. Honestly, it saves me the time and trouble of taking it out of the case and putting it back again. So here you go. You know, time is money. And finally, we're done with this build. Finally. Like and subscribe, and also tell me what was the most challenging thing you've ever done for a keyboard before. let me know. See ya.